This is a tutorial on how to assign color codes in a typical three-phase panel board or load center. We will assume a black, red, blue color code, which is one way to code a 120-208 panel. Brown, orange, yellow is a common color code for 480-277. Remember, these will vary across the country and even job by job because the NEC does not specify. We will be using modulo arithmetic. I won't go through all the special notation and processes. There are a ton of videos out there if you want more. I'll just use a couple of simple applications that should make sense and one that you probably use daily. For example, if we want to bake a pie and need 6 apples to bake one whole pie and we have 3 apples, how many will be left over? Well, if we need 6, we only have 3, we'll have 3 left over. Remember that for later. Here's another example. We need 6 apples for that pie. Now we have 8 apples. How many will be left over after we bake a pie? Well, it'll be 2. 8 minus 6 is 2. That's 1 whole pie and 2 left over. For bigger numbers, you can keep subtracting 6, but remember that dividing is just iterated subtraction. With 14, we could subtract 6 over and over, but why not divide? 14 divided by 6 is 2, right? That's the same as subtracting 6 twice. And there are 2 left over again. That's 2 whole pies with 2 left over. Maybe a more familiar example is a clock. If you think about a clock, we could use a 12-hour basis or a 24-hour basis or military time. For this example, I want to run military time. So, if you start a process at midnight and it runs for 65 hours, what time will it be at the end? Okay, you take 65 and divide it by 24. That'll give you 2.70833 days. Just like with the pies, we're going to subtract out the 2 whole days. We know it's 2 whole days. We're interested in what time it'll be at the end. 0.7833 times 24 gives you 17, right? So there's 17 hours left over. And 17 hours on a 24 format is 5 p.m., right? Military time, 1700 is 5 p.m. We could have done the same thing with the 12-hour format, but we would have had to think a little harder about how many full 12-hour segments we had to know if it was AM or PM at the end. Right? This is a typical 3-phase panel layout. There are other ways to number out a panel board. Watch out when you're in the field, but this is typical and what most of our problems will be based on. Anything I can think of in the curriculum we'd be dealing with when we're using a 3-phase panel board, we'll be using this type of a layout. So 1 and 2 are on A phase, as are 7 and 8, 13 and 14. Do you see a pattern if you divide by 6? 3 and 4 are on B phase. So are 15 and 16. Try testing that divide by 6 pattern again. Remember, with 3 and 4, we haven't hit 6 yet, so it's just like the pie. 3 and 4 are their own remainders. 5 and 6 are on C phase, as are 11 and 12, 17 and 18, on and on. Notice that 6, 12, 18 are all multiples of 6. If you know your 6 multiplication table and have some fingers, you can work out your own system. But we're going to keep it all consistent and work with a calculator so we don't have to memorize and potentially misremember something. right? So we'll review. 1 is on A phase, as is 2. As will be anything with the remainder of 1 and 2. B phase is 3 and 4, or anything with the remainder of 3 or 4. And 5, 6, or 0, right? Remainders of 0, those even multiples of 6, like 12 and 18, are C phase. In this case, blue. Could be yellow. Let's look at the next group of circuits and divide 7 and 8 by 6. That's 1, 6 with 1 and 2 left over. 7 and 8 are on A phase, black. 9 and 10 are 1, 6 with 3 and 4 left over, or B phase, red. And 11, 12 are 1, 6 with 5 remaining, and 2 6s with 0 remaining, blue, C phase. All right, so our next example is 13. And with 13, I'll show you the math to use step by step. Okay, we're going to take 13 and divide by 6. That gives you 2.166. And just like with the pies, just like with the days, we're going to subtract out the whole number. You get 0.1667, multiply that by 6, you have a remainder of 1, which is A phase, right? So now let's go deeper into sectionalized panel board. Take a look at circuit 57. Pause the video, work it out yourself, then check your answer. 57 divided by 6 is 9.5. 9.5 minus 9 is 0.5. 0.5 times 6 is 3. And 3 is B. I hope you find this useful for both your typical panel boards, also sectionalized panel boards with large circuit counts. And remember, there are other color codes out there like brown, orange, yellow for 277, 480. Here's a worksheet you could screenshot to practice on. I hope you find this useful, and good luck. Stay safe out there.